Right, grade 12s, in this lesson we're going to be going over and revising the trigonometric graphs from grade 10 and 11 and then extending it into the matric syllabus, linking into compound and double angles. Do you remember we had the amplitude shifts? We're going to be doing the amplitude shifts and the vertical shifts. Those were from grade 10. And then we came along to grade 11 and we did the period shifts and the horizontal. And now we're going to link it to compound angles. But let's revise all the graphs quickly. And what I want to start off with is the graph of y is equal to sine x. If you remember from grade 10, the sine x starts at naught. So the sine of naught is naught. The sine of 90 was equal to 1, if you remember, and there was a dot there. The sine of 180 was naught. The sine of 270, negative 1, and 360 is naught. Remember, just check that in a calculator, sine of 270 is negative 1. So you used your calculator to generate the basic graphs. So the sine x graph came up, it turns, it came down to 180, and then it went and turned to 270 and up to 360. The graph of y equals sine x. These are the critical points. By the way, the maximum value is equal to 1. The minimum is negative 1. The range of the graph, the y's go from -1 to 1. Do you remember with trig equations, when you're solving sine x as a number, you can never go beyond the -1 and 1. Okay, that's important there. Okay, so that's the range. The period is the other important concept, which is 360 degrees. The sine curve actually repeats itself every 360 degrees. So it goes like this, 0 to 360, and then it keeps going like that. It actually goes back as well. You can also have it going back as well. So that was the period. Okay, and then the graph of, if we look at it, the other one was cos. Now cos x, if you remember, if we use a little calculator, the cos of naught is going to be at 1. So if that's naught, the cos of naught's 1, then the cos of 90 is naught, 180 is negative 1, 270, and 360. So the cos graph almost looks like a cup. Comes down, and then it turns at 180, up to 270. Those are the x-intercepts at 90 and 270, and turns. Again, we've got a maximum of 1, a minimum of negative 1. The range of this graph would be from -1 to 1. And if you remember, the period is going to be 360 degrees. The cos curve repeats itself every single 360 degrees. Okay, so remember that. That's important there. Now, remember it goes like this, every 360 degrees. Alright, and remember the graph is also decreasing. If you go from 0 degrees here all the way down to 180 degrees, it's decreasing and then it increases again. Okay, how about, and now this one, the tan graph. This is so important. Y is equal to tan. A lot of people mess this graph up. Do you remember the tan of 90 is undefined? So you had asymptotes at 90. And then the period of tan, I'm just going to verify this is 180 degrees. It repeats itself every 180. But let's see how it goes with this period. What is period? Many students don't understand that. Tan of 45 is 1. Okay, if you work it out. So there's an important point there. The tan of negative 45 is negative 1. And at these asymptotes here, you get them at 270, 90, going on like that. The graph is completely undefined at that point there. Okay, so what actually happens is the tan graph starts like as it goes at naught, it passes through 45 when it goes up towards the asymptote, and then it comes this way as well. So the graph is forever increasing, and notice that the distance from there to there is going to be 180 degrees from -90 to 90. So the period's 180. So if you take 45 and you add 180, you get to this point there. 0 to 180 is there. Negative 45 to 180 is there. And the graph repeats its shape. Look at that. And does this. And likewise, if you go there and you go there, there we go. It's going. So this graph is repeating itself as you move from left to right. It's always increasing, but repeating itself every 180 degrees. The it's basically its range goes from minus infinity to infinity, and there we go. So it's important, those critical points. Now let's go on to what we call amplitude shifts. Okay, just to revise the amplitude shift quickly. Now remember that a graph of that, if we take y is equal to, let's say, if we take an example of 2 sine x, okay, an amplitude shift of 2 sine x, we need to understand what is amplitude. And what amplitude is really half the distance between the max and the minimum. Okay, so if you add up the max and the minimum value, half the distance between the max and the min, and you halve it, and this is the positive distance, half the distance between the max and the minimum. Okay, so we'll come on to that in a minute. So I'm not going to stress you out too much with this at the moment, but let's just see what the graph of 2 sine x looks like. Okay, here we go. Well, if you start at 0, and we're looking at y is equal to 2 sine x. So if I say x is 0 degrees, it goes 0. 0 times 2 is 0. At 90, if you go the sine of 90 is 1 times 2, it's going to be 2. So what happens is your basic sine curve kind of does this. That's your basic sine curve. And what happens is that these critical points are going to go and do a stretch. So the x-intercepts stay the same, but the 90 shoots up to there. 180 stays. The 270 goes down to 2. So what actually happens with this graph is that it goes up to 90, down to 180, turns at 270, 360, but the range is from minus 2 to 2. That is your minimum at minus 2, your max is 2, and the amplitude is really that number there. And what amplitude means is if you go from the maximum all the way down to the minimum there, the distance is 4 units. Okay, the distance is 4 units. All right, and if you halve that distance, which is 2, you get the amplitude. So that distance is 2, that distance is 2, the whole distance is 4, and that's what we call an amplitude shift. It's really the sine curve stretching up and down, stretches to 2 and negative 2, and remember your x-intercepts remain the same. So there we go. That's your amplitude shift there for sine 2x. Okay, and remember that the maximum is going to be the minimum is minus 2, and the max is going to be 2. Okay, all right. Let's have a look at another graph. If we go to, say, the graph of y is equal to negative 3 cos x. Now people, what I'm going to do here is I'm going to draw the basic cos curve. Okay, if you look at the basic cos curve, it basically went like this, down to there, down to there, down to there, and up, and here we go up to here. Alright, now when you get 3 cos, you have a stretch like this. Okay, so it stretches, and this stretches down to 3, and so it comes down like this and all the way up to there. Okay, up to 3. So you can see it goes there, but the moment you've got negative, now listen to me carefully. I want you to watch that. If you go 0, the cos of 0 is 1. If you multiply by negative 3, what is going to happen is that the graph, this point goes to there. The 90 and 270 remain fixed. The 180, look at that. The cos of 180 is negative 1. Multiplied by negative 3 shoots up to there. And it goes there as well. So this is a reflection about the x-axis. Look at your cos graph. It goes, the cup goes upside down. Do you see that there? Again, you have a range of minus 3 and 3. The minimum being minus 3, the max being that. But your amplitude, now listen to me, this is important. The amplitude is positive 3. It's half the distance from there to there, which is, this distance is 6. If you halve that, you get 3. But I always look at that and say, well, okay, it's negative 3. My amplitude is 3. And by the way, also, if you take, you could extend these graphs. If you look at sine, you could have actually done this as well. You could have taken it down to there as well if you wanted to, because the restriction would have been from minus 90 in this case. They could have probably given it to you like that, and you could have extended it down as well. And likewise for this graph for cos, you can continue it if you like. Okay, and it goes to there. Alright, so that's the graph from minus 90 to 360. So you look at your restriction. If it says minus 90 to 360, you would not only draw the basic curve, but you extend it in other directions. Alright, what about a graph like this? If we take the graph of, I'm going to go to here, black here, y is equal to a half tan x. And the restriction is going to go from, let's make up a restriction. We'll go from 0 degrees to maybe 180 there. Let's have a look here. We can go, or maybe let's make it from minus 90 to, let's make it to 180. That's interesting. Now remember, of course, it's open there because of the fact that you have an asymptote there. So remember, your asymptotes will be at minus 90 and at 90 there. We're going from negative 90 to 180. And where does your basic tan curve go? The basic tan goes always from there, from 0, passes through 45, 1 up. At 135 it would have gone down there, and likewise it comes down here. But what happens is if we sketch the graph now of a half, the tan of 45 is 1, but if you halve 1, you go down to half, so it's there. Look at that. So the graph does this. It almost drops down a little bit. And then here it comes up to negative a half. And likewise, if you then you go to 180 there, it comes down there. Look at that, to minus a half. And there we go. And that's your graph there. You can see it. So those points are very critical, these, to indicate them. Okay. Let me even color code them. It's important that you see them. Okay. In line. So there's no amplitude with this graph because you can't have half the distance between minus infinity to infinity. Okay. And the period is still 180. But remember, this number tells you where to start at 45. There you go down to minus a half, or to half, or here to minus a half. Okay, guys, very important graphs, these amplitude shifts.